Hello, my name is Hilda Joaquin, and today I'll be starting by introducing our group topic, which is our R&D efficiency in business strategies, particularly in high-tech industry. In high-tech industries, in high-tech industries, R&D performance is a key driver for success. Measuring efficiency, it's critical, especially for innovation driven firms like high techs, where investments in R&D are can lead, not always lead to expected outcomes. So this study is specifically focused on Taiwanese computer and peripheral firms, analyzing how well they utilize their R&D resources. Now let's address the main problem. How can DEA, data development analysis, can be used to measure R&D efficiency, and why is it important? Well, high tech companies are highly competitive, which means firms must optimize their resources to stay on top and to stay ahead. R&D investments does not always translate into performance. It's just like companies, just because companies doesn't always invest in innovation does not mean they will always see a significant result. There is a lack of clear metrics on how companies utilize their R&D resources. By applying DEA, we can quantify and identify companies that maximize their R&D resources and investments versus those who need to be improved.
So to measure the R&D efficiency, the study uses Data Envelopment Analysis, DEA, which is a method that compares companies to find the most efficient ones. So DEA evaluates the relative efficiency of decision-making units, DMUs, and in the article, it is the 31 computer and peripheral firms in Taiwan that serve as our DMUs. So it assesses how effectively these firms transform R&D investments into profits and patents. So the study applies three DEA models. The first one is the CCR model, which measures the total efficiency, assuming that the firms can scale up or down freely. The second one is the BCC model, which breaks efficiency into technical efficiency, that is how well the resources are used, and scale efficiency, which determines whether the firm is the right size. The third one is the P1 model, which suggests how inefficient firms can improve by adjusting their resources. So in simple terms, DEA helps benchmark firms against the best performers and identify what inefficient firms need to fix. So my teammate Hilda has already told you that the study was analyzed over 31 high-tech firms in Taiwan's Hsinchu Science-Based Industrial Park, and we are comparing the efficiency of these 31 high-tech firms. So the study uses 6 key factors. So our inputs, that is the resources which are used in the R&D, are R&D spending. That means the money that is spent on innovation. Second one is the R&D employees, that is the workforce that is dedicated to research. The third thing is paid in capital, which is the financial strength of the company. And the fourth is the firm's age, that is the number of years that firm has been in the business. And our outputs, that is our performance indicators, are the annual sales, that is the revenue generated, and the patents granted, that is the innovation output. So by looking at how well the firm converts inputs into outputs, the study ranks them from most efficient to least efficient and suggests improvements for those falling behind. So now let's talk about the results. So using the CCR model, the study found that 42% of firms were fully efficient. They were using their resources well and were on the efficiency front. However, 58% were inefficient, meaning that they weren't making the most of their R&D investments. So why were these firms inefficient? Many firms had increasing return to scale. They were too small and needed to expand their operations to improve efficiency. Whereas some had poor resource allocation, that means that they were spending too much on R&D without seeing results in sales or patents. And in the study, we saw that DMU4 was the most referenced efficient firm, which meant that it served as a model for inefficient companies to follow. So our big takeaway from this study was that R&D spending alone isn't enough. Companies need the right scale and structure to make it work.
So now let's look at what drives performance using the BCC model. The BCC model breaks down efficiency between technical efficiency versus scale efficiency. Technical efficiency is how well a firm used its resources to maximize production output. Scale efficiency, also known as economies of scale, is a company's ability to produce goods at a lower cost per unit as their production volume increases. Technical efficiency was relatively high with a 0.789 average. This indicated that most firms use tech well. Scale efficiency, however, was lower with a 0.668 average, and that indicated that many firms may be struggling with size inefficiencies. The key insight from this is that many firms had the technology but lacked optimum scale for efficiency. So diving deeper into scale, firms can operate in one of three categories. First, constant returns to scale is when increases in inputs yield proportional increases in outputs. For example, a 10% increase in inputs would result in a 10% increase of outputs. Efficient, well-balanced firms are placed in this category. Next, increasing returns to scale is when increasing inputs yields greater increases in outputs. For example, a 10% increase in inputs would result in a 15% increase in outputs. These firms need to scale up for efficiency. Lastly, decreasing returns to scale is when increasing inputs yields fewer increases in outputs. For example, a 10% increase in inputs would result in a 5% increase of outputs. These firms need to allocate resources better. The team's recommendations for improvement based on this case study differs between efficient and inefficient firms. For inefficient firms, we recommend to increase a company's scale. That would be investments in workforce, infrastructure, etc. Also, better resource allocation in R&D. This can be accomplished by better aligning their portfolio of R&D projects to reflect the business strategy, improving success rates of funded projects, focusing and not having too many projects for the limited resources available, and also limiting projects to those that may yield major breakthroughs and competitive advantage. These firms would benefit from adopting efficiency models from highly efficient firms focusing on scale efficiency. For efficient firms, we recommend maintaining R&D spending aligned with business goals. We also recommend improving go-kill decision-making to avoid unnecessary projects. Concluding with our key takeaways from this case study, DEA helps identify which firms are using R&D resources effectively. This is measured using technical efficiency and scale efficiency. Also, most inefficient firms need to scale operations, specifically those with increasing returns to scale. Finally, the study highlights the need for better decision-making in R&D investments. Efficiency isn't just about numbers, it's about strategy. The current information economy forces high-tech companies to compete by increasing R&D performance. However, scaling up without efficiency can lead to wasted resources, making balancing operational agility critical in this high-tech industry.